Great. Well, thanks for coming today. My name is John Doyle. I'm in the application, the middleware application product management team at JBoss. I took over product management of EAP6 about a year ago from Rich Sharples. I'm also responsible for our enterprise web server product, which is our Tomcat and Apache package. So today I'm going to talk to you a little about managing Java applications in an open hybrid cloud. If you've managed to avoid the open hybrid cloud tag this week, I'm impressed. I'm going to focus the talk on EAP today. We're not really going to talk about any other products. How many here are EAP users today? All right, pretty much everybody. How many people are on EAP6 already? Have applications running on EAP6 already in production? So just a couple in production. People working on it for development purposes already. EAP5 users. Okay, and EAP4 users? Okay, well, there's still plenty out there. We have extended life support for a reason, right? So you know, you've probably all heard about the open hybrid cloud this week. You know, it's Red Hat. It's how Red Hat sees the future of IT developing. You know, some vendors will tell you that you're going to be on a single stack on a particular environment. Everything's going to be in cloud. We just don't feel that's the case. You know, we feel that there's going to be a mix of, you know, your traditional, you know, on-premise data center applications that you're never going to move outside of your firewall. There's going to be some applications that you're willing to run on a public cloud, and then there'll be some applications that you want to run on a private cloud locally to have the benefits of a cloud, but to keep them inside of your firewall. So that's our strategy. You know, from my perspective, from working with EAP, one of the things that I find is the best benefits of the open hybrid cloud. And with, you know, the way Red Hat approaches the open hybrid cloud, which is with an open source and a mindset on open standards, is it gives you the ability to have portability for your applications. You know, from an application development perspective and a management perspective, this is the best thing about it. In a sense, you could say it takes, you know, the tagline of write once, run anywhere to the next level, right? Because you're not just talking about operating systems anymore. You're talking about environments that may be in your data center or out in the public cloud. So I'm not really going to talk about unified systems here, but portable workloads and open standards will, you know, be touched on as we go. So, you know, EAP6, as probably most of you know, it was re-architected from the ground up. And it was re-architected from the ground up with the intent of being the best application server for cloud environments. So what does that mean? What does it mean to be the best application server for a cloud environment? You know, we think that any application server for a cloud has to have these attributes. It has to have a high degree of automation, right? If you're running in the cloud, maybe it's OpenShift. You've got gears coming up and gears coming down as your workload shifts. You can't be managing these things individually, right? It happens too quickly. You have to have a flexible management. You have to have options about the way you manage the container that gives you the flexibility to do what you need. You obviously got to have a frugal use of resources. Who here is already using virtualization in their, you know, in-house data center workloads? Right? So everybody's already putting tight constraints on their resources, trying to get as much out of their physical hardware as they have. So you know, we're constraining the resources that the application server can run into. And EAP6 was definitely designed to run within a minimal footprint. You know, and finally, you know, it touches everything we do, an open platform. You know, we're all about open source. We're all about open standards. Open standards are going to give you most of the benefits that we perceive here. It gives you the ability to move your applications around. It gives you the ability to communicate with your applications and manage your applications in different environments. So talk about a high degree of automation. So in this picture here, this is a diagram of EAP6 standalone architecture. And what this really reflects is what was available to you with EAP4 and EAP5. So we're all familiar with the way you probably managed EAP4 and EAP5. While you had clustered instances of EAP, you typically managed with the XML files that were on the file system, and you managed them on a one-by-one basis, right? There was no overall management capability with them. And there were lots of configuration files. They were all over the container, and you had to know where they were, and you had to understand the context of what they were. So while with EAP6, we've maintained the ability to have standalone servers, because you don't always have a need for a large deployment of similarly configured servers, we've added the management capabilities into that. So you can still have standalone servers. They don't have to be in a domain, but we've got better management capabilities upon them. So the same APIs that you use in domain mode are the same APIs that you can use in the standalone mode. But this doesn't give you a high degree of automation. So EAP6 introduced the domain model to give you this degree of automation, right? So the domain model consists of several concepts. A domain covers everything that you see in that diagram over there. It's configurations, multiple configurations, management of servers, management of individual running processes, configuration of clustering, configuration of management usage, threading. All of it can be controlled through that centralized domain controller. Each gray box that you see is a separate physical host. Each of those physical hosts has a host controller on it. And a host controller and a domain controller are really the same process. A domain controller is just a host controller that it knows it's in charge of a domain rather than a single machine, right? On the right, you'll see two server groups. Those are the dashed lines. Server groups are our concept for a singular configuration. So all of the nodes, the servers that you see in those server groups, have the same configuration. Any change that you make to server group B is cascaded across every server node in group B. So this is where we get a high degree of automation, a centralized control point where you can control multiple configurations and have those changes cascaded out to multiple nodes in your environment. So it's worth mentioning here that clustering is a separate concern from domain management. So here we have server group A and server group B. That doesn't mean these servers are necessarily clustered. They could have workloads on them that don't need to be clustered. So it's a separate concern. You manage your clustering through your configuration, but just because something's in a server group doesn't mean it's actually in a cluster. It just means it has the same configuration. So once we've got the centralized control, we also don't have to have these hosts running within the same environment. So a domain can span environments. So just taking the same diagram before, I've added some additional boxes on there. You could run your domain controller and your main host controller within your data center locally on premise, right? There's no reason you can't share that configuration with servers out on EC2 or some other infrastructure as a service provider, right, like Rackspace or something. So you have the capability to share those out there. Obviously, there's concerns about clustering. You probably don't want to cluster a workload across your physical work, your physical lab, and a hosted cloud. But you can share your configurations across there. We have the capability to secure our management communication through either SSL or TLS, so that the changes you make through your configuration and the monitoring that you do, across the internet is secure. So this is one way that you could, implement some cloud bursting on EC2 or some other provider if you have hosts set up there with the proper configuration. You can just spin them up when you need them. They know where the domain controller is. They connect to the domain controller, and then you can start pushing configurations out there. So you could have an install of EAP6 out there with just the information to connect securely to the domain controller. It wouldn't have any configurations at all out there, and once you spun up that instance, you could determine exactly what kind of workload do you want to put out there. Do you want to put in the configuration from server group A or server group B? So you can have nodes ready to go with no configuration, and then push the configuration you need at the time that you need it. So another thing to note about the domain configuration is it's actually not needed in order to process your workload, right? So in case your domain controller goes down, all of your servers are running out there responding to requests normally. Your domain controller is there to do monitoring and to do management, to do changes to your configuration, but it doesn't actually affect the operation of the servers that are doing your workload. So we also do have the capability, host controllers have the capability that when they're started up, they can pull in the domain configuration and cache it. So in the event that a domain controller does go down and you can't bring it up, you have the ability to promote a host controller to a domain controller and reestablish control of your domain from a new node until you bring that domain controller back up. So that's what I wanted to say about, about automation. So once we have that high degree of automation, we have several options of how you manage that domain. And what we like to talk about most often is the command line interface. From a historical JBoss perspective, where users are managing through the XML configuration files, this is a huge improvement in manageability over what we've had. It's extremely powerful, you can do all the monitoring and all the management that you can do through any of the other capabilities through the CLI. So it's very, very cool interface. We also have a Java native interface. So we have a jar that we provide to you where you can write your own Java code to do management operations on EAP as well if you want to make some kind of framework for yourself to manage within your environment. We have a HTTP and REST interface. So if you want to send HTTP calls from some other language to EAP, you can do that as well, or REST-based calls. A graphical console. We had multiple consoles in earlier versions of EAP, but it wasn't unified. So we had the capability to make changes in various subsystems, but you didn't have an overall look at the application server. So in EAP6, everything's been pulled in to the single configuration and into the graphical console. So it all has the same look and feel. And then finally, we don't want to leave out our option of JBoss Operations Network. Everything that I talk about in the management operations at the top, these all apply to individual instances of EAP or domain-based configurations, right? What that doesn't give you, it doesn't give you control of EAP4, EAP5, or EAP6, right? This is only EAP6. So if you have, an environment where you're running 4 and EAP5 and EAP6, and you want a singular way to manage EAP, JBoss Operations Network is your answer, right? It can manage multiple versions of EAP and give you that same look and feel through the John console. Oh, sure, please. John can work with the domain model. There are some limitations to it. Off the top of my head, I can't list them off, but there are 1 or 2 limitations about it. We could chat about it after. I think Alan's here. He could help me out with that after the talk. So if you're interested in that, we can talk about that after. But it certainly can work with domain mode. There are some limitations. So here's an example of the management CLI. So the CLI is transactional. So any command that you make or any batches of commands that you make, if there's an error, they can be rolled back. So changes to the container won't happen unless the command is successful. You can use the CLI with both standalone or domain models. It's a bit of a Unix-based shell syntax. So you can call it up and you can interactively make commands with the AP. But you can also use it with scripts. So you could write your scripts out with commands that you run often, and then just throw those scripts to the CLI and execute it that way as well. It has similar address-based operations, if you will, where you can drill through the subsystems of the AP and run operations on individual ones. But it also has some high-level commands as well to deploy applications and undeploy applications and create subsystems as well. And all the changes that you do through the CLI, they're all persisted into the XML files. So anything you do here gets back to the domain XML, the host XML, the standalone XML configuration files. Down the bottom, we have just an example of creating a new data source and flushing that data source. Actually, not creating it, but switching into the data source and flushing the data source connections.
So the CLI command will allow you to control commands at the EAP level or at the reach level?
At the EAP level or what level?
Or at the host controller level. At what level can we run the commands? Can I do the commands for multiple EAP hosts, or I have to do it on one host at a time?
So you can connect to individual host controllers if you want, but typically you will connect to the domain, and then you'll communicate with individual hosts through the domain controller. But you can go direct to a host controller if you choose. So this is just an image of the web console that we have. This has been a big addition to EAP6 as well. I know internally, we like to use the CLI. But some people, they've never used CLIs like that. Maybe they don't come from a Linux or a Unix background, so they're not comfortable operating in that environment. If somebody's been working with WebSphere or WebLogic for a number of years, they're probably used to working, in a graphical console. And it's something that, we've never been particularly competitive with. So, with 6.0, we introduced our graphical console. We're bringing it forward with new capabilities in each release. It's simple, it's fast weight. You don't have to touch XML if you're not, if you're not handy at the command line, if you're not comfortable at the command line, it's a great option for you. It can manage both single instance versions of EAP and domain configurations of EAP. So you can manage your server groups configuration. You can create new instances of EAP running on hosts that already have host controllers running on them. So you can just take a particular configuration and say, run 2 more nodes of it on this machine and 1 more node of it on this machine. So it's very powerful. It has some basic monitoring capabilities in terms of thread usage, memory usage, transactions. But again, I want to insist on that it's not a John replacement. It doesn't have all of the complex monitoring that John has. It has simple level of monitoring, and you're not able to modify the look and feel and create dashboards within this console today. So John still has more capabilities here, but it's a great enhancement for EAP for customers that that are comfortable in a console. It's a great way to go. So I've touched on it a few times. John is still and remains our premier management tool for all JBoss products, not just EAP. John's capable of managing all versions of EAP, but it's also capable of managing all the JBoss products. So if you've got SOA or Portal in your environment as well, and you want to have a single pane of glass for all of those, John is really your answer. John also has some provisioning capabilities that go above and beyond what EAP has with its bundling capability. It has drift management so that you can see what changes have happened in your configuration over time. It has alerting, so custom dashboards. So it's a much fuller management solution than what we have in EAP 5, and especially if you have other JBoss products, in your environment, you should look at it and consider it. So that's what I wanted to say about flexible management. In terms of frugal use of resources, these graphs are a little dated, but they're mostly accurate. Where they're not accurate is that we're actually faster now than we were when these graphs were created. So if you look at these, you'll see the big red line is EAP 5.1. It had a cold boot time with no applications of 27 seconds. We made some changes with AS6 that have made some performance improvements, but AS6 was never converted into a version of EAP, so that's purely a community project. And then you can see that AS7 really dropped out to the bottom in terms of cold boot time. And similarly, you can see AS6 has big memory consumption, and AS7 dropped the memory consumption down to a fraction. What's important about this, and why is this valuable? I mean, everybody wants to use less memory, and that's all great. But when you're deploying into cloud environments and virtual environments, people are constricting the resources. They're trying to get as much out of their hardware as they possibly can. So the fact that the container itself is using so much less memory frees up more memory for you to pack more applications within a particular slice of a virtual VM or a cloud instance. Cold boot time is also important as well. If you're doing cloud bursting, if you're looking at OpenShift and you're bringing up gears as additional workload comes in, 1 second versus 27 seconds for a gear to come up, it's quite important, right? I mean, this is going to help you to scale your workloads rapidly as you need to. So there's many enhancements that went into EAP 6 in order to give you, the improvements that you've seen. But one of the most important ones comes under the JBoss modules project. JBoss modules is the foundation for the way all of the subsystems in EAP are loaded, as well as the way all the applications deployed into EAP are loaded. So this graphic is a graphic of sort of how traditional class loading happens in an application server. You deploy your wars, you deploy your ears, and those class loaders will defer to parent class loaders, essentially searching to load all the classes that it needs. I like to think of this as getting dropped off in a city you've never been, looking for a restaurant that you only have the name of, but you don't know what street it's on, and you don't have a map, right? So there's a lot of time, a lot of effort, a lot of searching, a lot of processing power spent to do this kind of work. JBoss modules, on the other hand, is simple and it's declarative. All of the subsystems in EAP declare their dependencies directly. So when JBoss modules loads a subsystem for your application, it knows exactly what it needs to load. And it takes advantage of the modern multi-core processors that we have today. So in the traditional class loading, all of that work was happening in a single thread, right? So it takes a long time. JBoss modules can use all the cores that your environment has handed over to EAP to do its loading. So there's much less searching involved, and it can do it in parallel. Versus, Well, so OSGI is a much larger, specification than just purely loading. So JBoss modules really only does a subset of what OSGI does. But OSGI still has, I would say, I would characterize it the ability to do class loading resolution above and beyond even what traditional Java class loading is, right? Because you have the ability to register your plugins with different versions, and plugins can have preferences upon these versions. So that's even a more advanced and more difficult process to load. So in a sense, JBoss modules simplifies it because it has a simple declarative language. You have to say exactly what your dependencies are up front, and JBoss modules can very quickly execute on that, right, without doing any searching. OSGI goes in the other direction, right? It expands the capabilities even more, which puts more burden on the loading infrastructure. So JBoss modules is really optimized for speed here. And OSGI, I would say speed, while everybody wants their code to run as fast as possible, I don't think speed is a big consideration in OSGI. Flexibility is a bigger consideration, and flexibility has a cost. So we're both solving the class loading issue, but we're solving it in very different ways. So finally, the last bullet point on what makes a cloud-ready infrastructure is open platform. Open standards are really essential for success here, right? We start out with the foundation that obviously we're an EE application server. So you've got the foundation of those EE APIs to rely upon. But it also it comes down to the communication protocols that we use, and all of these things, open standards and open source, are really in the DNA of Red Hat and JBoss. All the work we do, it's all open source. Every time we have the capability to choose an open standard, we will choose an open standard rather than come up with an individual, implementation of ours that overrides a standard. And when we can't find a standard that suits our needs, we are very much in the business of creating new technologies and driving those technologies to standards. So even in the case where we are creating our own implementations, new technologies, new implementations, we're always looking to drive those implementations to standards. And we have a history of that. We started out with Seam, which was a JBoss product, and that pushed that into the CDI standard. Hibernate as well. Hibernate was an individual, project that came into JBoss, and it formed the foundation for JPA. So, in the case where we're developing new technology where standards don't exist, or the existing standards don't meet our needs, we're always looking to push those technologies into standards. So in the future, you'll be able to take that and move that around as well. So we do have some new features in EAP 6.1 that went GA last month that are, and this isn't a full rundown of everything that's in 6.1. This is just things that I thought were pertinent to our talk here today. So within the configuration for EAP, from the very beginning, we've had the capability to drive your configuration off of environment variables. But what we didn't do when we put that capability in is we didn't really do a top-to-bottom audit of all the attributes of the configuration, of all the attributes of the various subsystems that build up EAP, and make a determination about which of these attributes should be open to environment property substitution and which ones shouldn't. So once EAP 6.0 went GA, we started to get a steady stream of, could you open up this property? Could you open up that property? So for 6.1, we essentially did a top-to-bottom review of what was there and made determinations about what shouldn't be open to property substitution for some implementation-specific reason. And where it made sense, we opened up the configuration to property substitution. Now, what's powerful about this is this allows you to drive, your running instances in different environments based across the same templatized configuration, right? So you can reduce the number of configurations that you have to maintain and then drive those configurations on startup from their environment variables that are specific to where they're running. We also have the new capability that's of something called CLI archives. And this provides you the ability to combine application deployment and environment setup within EAP into a single deployable artifact. So, a very common example is somebody will have an application that they want to deploy, and that application needs some queues set up in order for it to function properly. So, there's the potential for error here if somebody doesn't set up the queues in advance and deploys the application. So, there's a couple of ways you could go about that. You could have a script, that creates the queues and then deploys the application. But then you've got a management where you're managing a script over here and a deployment archive over here. So CLI archives gives you the ability to combine these into one package. So it's simply a jar file. It has a .cli extension. It contains one or more deployments that you want to deploy into EAP, and it contains a deploy and an undeploy script within the CLI. Use the standard deployment CLI command to deploy the CLI archive, and the scripts that you provide are run on undeploy and deploy. So for instance, an application that needs queues, your CLI script would simply read create queue or create topic, and then deploy, particular ear. And your undeploy would do the exact opposite. So it would deploy the war and then close off the queues. And this gives you the ability to keep, the configuration and the applications in one place and do it and deploy it in one transactional step. So some features coming in 6.2. 6.2 is going to be a very, very big release for us. We have two major features coming that have, people have been waiting for a very long time, both customers and internally. So one of those features is patching. This gives you the ability to do in-place patching of EAP. This will work for individual instances of EAP. We'll be able to provide for you CVEs, so security fixes that you get that are produced by our security response team. Any one-off fixes that you've gotten from Red Hat GSS. We're also looking at the possibility of doing cumulative patch fixes, and we're having discussions with customers about how they'd like to see cumulative patches or if they'd like to see cumulative patches for their environment. So if you're interested in talking about that, I'd be happy to talk to you about that after the chat. And we even have the possibility of doing minor releases. So we could move you from a 6.2 to a 6.2.1. So the capabilities coming in 6.2, we're discussing with customers what's the best way to use it, for their particular environments, what kind of patches would they like to see, what kind of tempo would they like to see them released upon. So patches will be installed through the management interfaces. You'll be able to get reporting from the management interfaces about what patches have been installed on your instance. You'll be able to roll back the patches that you've installed as well. So if you put a hotfix in that you get from GSS and you realize that it doesn't actually fix the problem you've been reporting, you'll be able to roll back that patch back out and go right back to the configuration you were running before with no changes. The other major feature we're looking at for 6.2 is role-based access control. Customers have been asking for this since oh, I don't know, EAP 5 maybe, certainly since I started working with EAP. Today we have basically two roles in EAP. One's an application user and one's an administrator. And if you're an administrator, you're super user. You get absolutely everything, right? So this is typically not what most people want to provide to their teams. So the role-based access control we're looking at, they will have users in the system. Those users will be attached to roles. We'll have the capability of mapping those users to the roles in our user interfaces. You'll be able to pull those users in from external repositories, LDAP, Active Directory. There'll be capability to do some constraints on the existing roles. But what we are coming out with initially in 6.2 is a role-based system that has a series of fixed roles. So you're not going to be able to create your own role with your own custom permissions in this release. We are looking at improving it over time to make it more flexible. But for this release, we're going to have several fixed roles that you will be able to constrain in some places. So the lowest capability role is the monitor role. And that simply allows somebody to look at running servers and read the current state of the servers. An operator role is the combination of everything a monitor can do with the ability to stop servers, to restart servers, to pause JMS queues, pause JMS topics. A maintainer role is an operator role, and they have some ability to modify the configuration and deploy applications, create queues, and things like that. A deployer role is basically a maintainer role that has some constrictions applied to it. So he's a maintainer, but he's strictly limited to application concerns. So he's not able to make major changes to the configuration outside of what touches applications. Finally, there's an administrator role. He's a maintainer, and he has the ability to configure sensitive items like security, like the role-based access control system. He'll be able to map users to roles and things like that. And finally, an auditor log, which gives you the ability to monitor and view just the resources related to audit logging. So in some organizations, there's somebody who has no capability to make any changes to the system, but they're responsible for security. So that's what this role is looking for, somebody who's just looking at the auditing. And then finally, we're going to have a super user, and that's the equivalent of what you get today with EAP 6 with an administrative user. So that's pretty much what I wanted to have to say today. There were some questions earlier this week about specifically managing EAP 6 in OpenShift, and it's a bit of a conundrum to me because when I think of OpenShift, I think of somebody who doesn't want to do any management of the container at all. So we do have on our roadmap, we are looking at putting some John management into OpenShift. And that'll give you the ability mostly to look at monitoring of your OpenShift environment so that you can see what's going on over there. But generally, from an application development perspective, the use for OpenShift is I don't want to be bothered with the container. I want to focus on my application. So from an EAP perspective and from a development perspective, what's great about OpenShift is the EAP that's running in OpenShift on-prem or OpenShift hosted, it's the exact same EAP that you're going to run on your developer workstation. So to go back to the beginning when we were talking about application portability, what's great about OpenShift is you can have an environment where your developers don't need to do any management of an application server at all. But when they develop that application on OpenShift, it's going to deploy to OpenShift Enterprise. It's going to deploy to your data center where you're running EAP. It's going to deploy out to EC2 or Rackspace if you're running EAP out there as well, because you're building off of the same dependencies that are delivered in EAP with the hosted Maven repository in OpenShift, or the Maven repository that you use in a traditional development work environment. So it just gives you that great application portability. But from a management perspective, it doesn't really fit in.